TopMedTalk. Well, hello, and welcome to TopMedTalk Down Under. I'm Andy Cumpstey, and I'm here with my co-host Kate Leslie at the Australian and New Zealand College of Anaesthetists and Faculty of Pain Medicine's annual scientific meeting in Brisbane. We're both at our booth at the Healthcare Industry Exhibition, and it's been another really fantastic day at the conference, and we've had another great opening session this morning.
We heard a wonderful lecture about obstetrics, and then we had a great lecture about translational pain program in Canada, which is really relevant to anaesthetists, for our surgical patients. And then finally, we learned a whole lot of stuff we didn't know about the pharmacology of induction and emergence from anaesthesia. So it was good.
Fantastic way to open the day, wasn't it? Really, really inspirational. And again, some of the case presentations that we saw were really quite emotional, actually.
Oh, I love an inspiring video.
Yeah, it's
surging orchestral music.
Yeah, it was really well done. Very well put together. Well, today we've got some more great interviews planned, both with local and international speakers. And again, links, as always, will appear for every episode on our conference newsletter, on our TopMedTalk app, on our YouTube channel, and through our X and Facebook accounts. So make sure you can join our conversations.
Right now, though, we've got some great guests to talk about flying, climbing, and all things oxygen, and with a bit of a twist on history as well. So, Chris, can you tell us a little bit about yourself first?
Okay, so I have been the Honorary Curator at the Geoffrey Museum at the college for 35 years now, which makes me part of history. So I've had a lifelong interest in the history of anaesthesia. I'm also currently working at the Alfred and at Monash University, where I have an interest in perioperative medicine. And I'm currently the Wood Library Museum Laureate of the History of Anaesthesia in America, which is a 4-year appointment, and it has been a very great honour. So, yeah, that's a synopsis.
Dan, can you introduce yourself?
My name is Dan Martin. I work at the University of Plymouth in the southwest of England. I work on primarily the intensive care unit at Derriford Hospital now. And I have a research set up at the University of Plymouth, and we are looking at both the sort of effects of too much and too little oxygen. So carrying on research that I've been interested in most of my life now. I'm really enjoying life, having moved from London to the southwest for a different kind of life, and it's really working out well.
Terrific. So it's sort of a translation from the mountains to the clinic and the city to the regions.
Yeah.
Yes. So Chris, starting with you, human beings have always been fascinated with flying and leaving the ground and inventing new bits of kit to help them do that. And you've looked into that for your talk yesterday. Can you tell us a bit about that?
I think the fascination with getting up high as a sport really began around the middle of the 18th century, just before the French Revolution, and there was a lot of work happening in France. So I told the story yesterday of the Montgolfier brothers balloon, which was launched from Versailles about 1770-something, just before the French Revolution, when everyone was still intact. And Louis XVI was a patron of a lot of these explorers and scientists. So the Montgolfier brothers had made a balloon to get them up into the air, but everyone was too scared to actually get in it. They knew that it could ascend, but they had some doubts about, I guess, getting back down safely. So they thought they'd do an experiment with a sheep, because a sheep would be a good approximation of a person. But then, because they were sort of scientists, they decided that they'd put some controls in the basket. And the first control they put in the basket was a duck, because ducks are known to fly at altitude, and they thought, well, if the duck survived and the sheep didn't, that would prove something. But then they realised they needed another control for the duck, so they put a rooster in the basket. So a sheep, a duck and a rooster made the first successful balloon flight in about 1775. They flew to 1,500 metres. They landed 8 minutes later, still in the grounds of Versailles. And when they got there, the duck and the rooster were unconscious, having been knocked out during the landing, and the sheep was just grazing on the grass. So that controlled experiment went well, and men just got into balloons pretty quickly after that. But they realised fairly quickly that if they ascended too high, they would lose consciousness. And fortunately, the first person that did that a few years later quickly realised he was getting very sleepy and that he probably wouldn't wake up, so he came down rapidly. And it was a long time before they went back up that high. It was at least another 80 years, but they stayed around down in so where they could view the landscape.
And you gave some fantastic stories of this yesterday, but how high are we talking about when people started doing this?
Well, so they were getting to about 28,000 feet.
Right.
And possibly even higher. some of the early balloon flights at extreme heights in the 1800s were really dangerous and in fact fatal. So we don't really know exactly how high they got because the recording instruments were probably damaged or not that reliable. But
so just to be clear, they were setting off from the ground and rising straight up to almost the height of Mount Everest.
Yes, yeah, right.
Which is,
mental.
pretty mental. Yeah, absolutely. And what sort of symptoms were they getting?
I think predominantly the first thing they were finding is they couldn't use their hands, which became problematic once they introduced oxygen, which was a good 100 years later. They realised that oxygen might help them. They took the oxygen, but they couldn't use it because they couldn't actually use their hands. And then they'd lose consciousness. I mean, it was very dramatic, very quick.
Yeah. So maybe that's a good point to come to you, Dan. So we've climbed together lots of times before and worked on the mountains before, but for our international listeners at home that may not know all of this, do you want to give a kind of brief summary of some of your adventures in the mountains over the years?
Thanks, Andy. Well, we've certainly never ascended a mountain the size of Everest in a matter of hours.
No.
Or that, I think we would consider that actually quite foolhardy. Over the past, 20 years now, we've had a series of research expeditions at high altitude. The first that we did all together was about 2003, just some simple experiments using bits of kit we found on the Middlesex ICU and took those to Nepal just really to see whether it would be possible to do this sort of thing at high altitude and to whether we could bring back useful data that would be meaningful to patients. Following that, the sort of scale of things escalated quite dramatically. In 2007, we took a couple of hundred members of the public with us to the Everest region, trekked to Mount Everest base camp, studying people as they ascended at various laboratories on the way, and then a smaller cohort of investigators as they climbed the mountain up to the summit, so studying them right up to the summit and back down again.
And just to contrast that to what Chris has just told us about, the summit team in that trip took roughly how long to get to the summit?
We summited, for us, our expedition, it was roughly about day 60 in the expedition.
So 60.
So I think you're there probably at about 60 minutes. And we had about 60 days, in which time enormous physiological changes happen to try and get you used to that sort of altitude in sort of multiple organ systems. And there's almost no time at all to adapt or change in the sort of minutes and hours that you hear about in these balloonists. So very contrasting physiological stimuli.
And when did physiologists and doctors and mountaineers work out the physiology of altitude? When did that start?
So I think they started to realise really around the turn of the 20th century. I mean, they knew about oxygen by the middle of the 1800s, that would be helpful. But it was really in the early 1900s that they were discussing acclimatisation. They were starting to understand the hemoglobin dissociation curve. They were postulating that you would be able to climb Everest with sufficient acclimatisation. And when there was a big talk at the Royal Geographical Society in 1916 where Alexander Callis discussed the fact that he thought you could get fit enough and acclimatised enough to get to the top of Everest. But at that time, Everest was closed to climbers by the government. So they were doing a lot of preparatory work and starting to plan to get up Everest. By that stage, it had become the goal.
And Dan, would you mind reminding us about the physiology of acclimatisation?
I guess the basic description is really one about bringing back the systemic oxygen delivery that you lose when you go to altitude. So to compensate for the low level of oxygen in the body, you number one, you breathe a bit faster. You can feel that if you've ever been up a ski lift or anything and get out and run around a bit, you'll feel a little bit more breathless. That's the first part of acclimatization. The second part is that your heart rate will increase. And again, you can feel that yourself in your pulse if you go up to altitude, which will improve your cardiac output a little. And as you spend longer and longer time at altitude, your hemoglobin concentration rises. And I think that's the one we all kind of think about as the key determinant of acclimatization. But that really takes days and weeks to occur, whereas the increase in your breathing rate and depth and the increase in heart rate occurs within sort of minutes and hours. So it's sort of combination of processes of these kind of gross physiological changes. And there are a lot more subtle things going on sort of beneath the scenes to augment that too.
There's changes in the oxygen hemoglobin dissociation curves that I remember learning in my primary exam. Can you recap those for us as well?
Oh, okay. Now you're going to put me on the spot. So something that has been quite controversial, and I think different groups argue sort of against each other about whether there is or is not any change in where the hemoglobin, oxygen hemoglobin curve sits. And I think overall, I think that the stance that I would take is it doesn't really move much at all, because you've basically got things that are occurring in opposing directions. So you hyperventilate so that your carbon dioxide falls and you'll move in one direction. The hypoxia that's there causes a release of 2,3-DPG, which will move it in the opposite direction. So you get it's sort of pulling and pushing in different directions. But I think what little has been done in this area would say that it sits about in the centre of where it should be. I don't know if you would agree with that, Christine.
Yeah, I think so. But I think when they were starting to understand it, it was all very new physiology, and at least they understood that there was some changes in the bloodstream and in your physiology that would mean you could acclimatise and you could eventually climb without oxygen. And you have to remember that climbing with oxygen was going to be incredibly difficult at that stage, because there wasn't the ability to make nice lightweight cylinders. It was going to have to be incredibly heavy cylinders, and they really had no concept of what that was going to involve. And when they first set off with oxygen equipment in the 1920s, when Everest opened up, they were carrying 15 kilogram packs with 4 cylinders and all sorts of safety gear that they had adapted from aviation that they probably didn't really need, because when they were making equipment for pilots, obviously, if a pilot went up very quickly and lost consciousness, that would be a terrible thing. So they had all sorts of safety valves and swap over things in case oxygen cylinders emptied and that sort of thing. And they set off in the mountains with that sort of equipment. And then they realised, of course, they didn't need that, because if you're on a mountain and start to feel unwell, you could just sit down and rest. But a bit different to being in a plane where it's fairly crucial that your equipment doesn't fail.
And that oxygen equipment led to some interesting decisions on the mountain as well, didn't it? So when Mallory was ascending in the 1920s, Sandy Irvine was chosen to go with him because of his expert knowledge about the oxygen equipment as much as anything else.
Yeah, so Mallory was quite resistant to oxygen in the first place.
Yeah.
So the first expedition in 1922, when they set off, Mallory went up first without oxygen, set a world record of 26,000 something feet.
Yeah.
Then came back down because he couldn't go any further. And then George Finch went up a few days later with oxygen and only got a few, like 100 feet.
And again, for our listeners at home, Finch was a chemist by background, wasn't he?
Yeah, and an Australian. Yeah, he's quite a controversial figure in the climbing world. I mean, I'm not really that up with mountaineering history, but when you read about the history of oxygen and mountaineering, he gets quite a bit of airplay because he controversially wasn't picked for the 1924 expedition. And there's a lot of feeling there was a bit of a maverick and, a bit outspoken, and he was very keen on the use of oxygen.
Well, he was different, I think. That's the
Australian.
That's not what I meant. I mean, he was different to the time in terms of pushing the oxygen delivery.
Yeah.
And that was very, very new at the time.
Yeah.
And again, maybe that links to some of the things that you talked about, Dan, in your plenary talk about you've had some interesting views thrown at you over the time where things have not necessarily been accepted by certain people, but actually have turned out to be very successful.
I agree, and it is, and I also don't know the sort of details of the story of Finch, but you do often wonder whether things would have been a bit different had they made different choices then. Absolutely.
Yeah. And maybe that's another good link. So we're talking a lot about oxygen delivery here, but that's probably one of the links into clinical practice, isn't it? So although this is interesting for history's sake, and it's obviously useful and relevant to people looking at physiology for their anaesthetic exams, but actually there is a real link to clinical practice and what we do every day. Do you want to?
Yeah, and I think basically from a lot of the work that we have done at high altitude, it's just made us sort of stop for a second and think about our use of oxygen in hospitals overall, and be that in a perioperative setting or in an intensive care setting. And after we come back from Everest, there's really not any work had been done to look at whether, what is the right amount of oxygen to give to patients. And I think that landscape has completely changed now. And there are numerous trials going on, both in the perioperative and in intensive care arenas, just trying to work out whether we're giving perhaps a little bit too much oxygen to patients, which is certainly possible. Oxygen, I think we often forget that oxygen is actually a highly toxic gas. It's whilst it's obviously essential for generating energy in high concentrations, it's quite toxic. So it produces oxygen-free radicals, which can be harmful to all of our tissues. And I think we've just probably quite rightly for a while, our stance has always been, if in doubt, just give oxygen, just like that'll get you out of trouble. And I think that is often true in a very acute situation. But failing to turn that oxygen down again after that emergency has passed may have caused unnecessary harm to patients. So this is some of the work that we're trying to ascertain whether it's possible to just use a bit less oxygen now for both ICU and surgical patients.
That's really interesting because at the Alfred, where I work, for cardiologists did a really interesting trial on oxygen use after myocardial infarcts, and all the protocols have changed in Victoria now. They don't administer oxygen routinely to acute myocardial infarcts, which was just so fundamental to our training. I find it quite difficult to not automatically just turn up the oxygen.
We used to have Mona.
Yeah, absolutely.
Morphine, oxygen, nitrates, and aspirin. So now it's Nimona.
And this is the Avoid trial that you're referring to, isn't it? So we've talked about this on TopMedTalk before, but I mean, that's a really important kind of transition point in this oxygen story, and that all of a sudden patients who would typically be given oxygen at the first presentation as they walk through the door were not. And if they arrived in the emergency department with saturations above 94%, they now get room air. And it's completely changed practice.
It's changed outcomes.
Yeah.
Yeah.
And again, that I think it's fair to say, Dan, that we're probably a bit behind the curve on that journey in anaesthesia, but we're maybe a bit further on in intensive care.
Possibly, yeah. But even in the cardiology field, if you actually look back into the literature, it's a whole series of reasonably well-run studies in the 1950s and 60s, which showed exactly this in the setting of acute myocardial infarction, but we chose to ignore them because it didn't seem biologically plausible. Yeah. It was like, how could there possibly be a situation where there's what we thought is not enough oxygen going to the heart, and you give oxygen and it leads to a worse outcome? So it's a fascinating example of us just ignoring the actual evidence. Certainly we are behind the curve in terms of that story, but I think slowly catching up, particularly intensive care medicine. If you've kept up with the literature in the last few years, the trials now looking at what we would call a conservative oxygen therapy approach to patients, the trials are getting bigger and bigger and bigger. The problem is the difference in terms of survival that it might make are ultimately quite small, but even though it's small, it's important because we're treating a large number of patients. Yeah. So what that leads to is that we need these massive trials to answer questions like this, the kind of trials that are now ongoing.
So what sort of trials are those?
So the two big trials are going with, the trial we're running in the UK is called UK ROCKS. We are 14,000 patients into a total of 16,500 patients, looking at a conservative oxygen strategy versus usual care. And there's a trial based in Australia and New Zealand, the Mega ROCKS trial, run by Paul Young and his group, aiming to recruit about 40,000 patients. I think they're more than 50% of the way through that now, using a similar strategy to our own. And we've kind of designed the trials so that at the end of them, we'll be able to lace the data together and look at it as if it was one giant.
Fantastic.
Yeah.
Both of those trials, I think, have interesting methodological aspects to them, which involve either delayed or waived patient consent. Our listeners are quite interested in trial methodology, so can you tell us a bit more about that?
We thought it was important to have a consent waiver process, or deferred consent. The sort of terminology is different in different countries, because what we're trying to do is to get in and give the intervention as early as possible once someone has become sick. What we certainly found out with the pilot study we did before the main study is that when we approached families and said, look, that we'd like to put your family member in a trial which involves oxygen, they were immediately concerned about this, and most of them could largely not answer the question. It's not that they didn't want them to be in the trial, they just said this is too much information given that this is already a stressful situation. So most ethics committees now in that urgent care situation will be happy to support a consent waiver process so that you can enter someone into the trial. Our advice is we wait sort of up to 1 or 2 days until a family is perhaps in a better emotional situation to be able to speak to them and then say, look, they're in a trial, this is what we've done. And we found very, very few families out of the 14,000 patients that we've randomized so far who've said, look, this is not what that person would have wanted. Almost all of them say, thanks very much for not speaking to me earlier on. We appreciate that. Just carry on doing what you're doing. So I think for a large majority of families and patients, this is a really successful way of running trials.
And another interesting thing is your a priori decision to do an individual patient data meta-analysis. And that's a growing trend and a wonderful sign of less polarisation and less competition and more collaboration among international clinical trialists. It's really wonderful to see.
Absolutely. And we did it like that rather than just making it one big trial, because I think there were subtle differences in the way that we wanted to administer the intervention and to run the control groups, which meant it couldn't be one trial. But we were very clear that we did want to join the data up again at the end of it, because it would be silly not to. So we've made sure that the outcomes are collected at the same time or will integrate together. So we're looking forward to being able to put that together, because at the end of the day, that'll be more than 50,000 patients in a trial.
That's amazing. So great. Can't wait to hear the results. I've been dying to ask you, Christine, about women and hot air ballooning and history, because you did mention that it was the chaps that went up, and probably a male sheep as well. There was a thing in the 19th century of women doing pleasure tours in hot air balloons and things like that. This is a question without notice.
Yeah, it is a question without notice.
Yeah.
It's not one I can really answer, but I do know there were some women chemists around at the time when they were first distilling oxygen and then using it. So just after Priestley discovered oxygen, about 20 years later in Bristol, they set up the Pneumatic Institute in Bristol, where they were trialling all the medical gases for patient care, mainly tuberculosis, I guess. And there was a woman patron, I think just the Countess of Devon or something. I really don't know the details, but there was a woman patron and there were some female chemists involved. But it's, I don't know all that history. As for balloons, I really don't know. But the other thing about balloons that we should mention is that they became quite heroic in France because they were used during the Franco-Prussian War. I think that's the first time they were used in warfare to evacuate from the siege of Paris. So 1871, when Paris was besieged by the Prussians, they used balloons to get news out about what was happening and to get people out. And they had planned to bring them back in, but they didn't have enough expertise with the currents and the air and everything. They never got anyone back in, but they got a lot of people out. So balloonists became really like war heroes in the 1870s.
And were the balloons beautifully decorated? And
They do seem to be, but the thing that strikes me about it is there's just a basket, right? They're just sitting in a basket, just going up to some ridiculous height, risking their lives. And it looks like it's about waist height, These guys were nuts.
I think it's a fascinating question, though, because when I realised after I put together my talk about the history of high-altitude physiology, there was only one woman in it, Mabel Fitzgerald. And I am a nerd about whether I should really focus on this, because I felt quite disappointed that at the end of it, I was just giving a talk about a whole load of men. And that's really not a great thing to do. And even Mabel Fitzgerald, who was involved in the Anglo-American Pikes Peak expedition, I think she wasn't allowed to participate in the science at the top of the mountain, so she helped out with some of the stuff down below, but was an incredible scientist and did a huge amount of the associated lab work and science with it, but was never really credited much in terms of her contribution to that particular expedition, which is really disappointing. So
you showed some interesting slides yesterday about the differences in oxygen uptake in men and women and in fit men and women as well.
On average, males will have a higher VO2 peak or VO2 max than females. I don't know what the reason for that would be, and it may be to do with muscle bulk. If you've got more muscle, then you will consume more oxygen. So on the whole, women will always tend to have a slightly lower mean VO2 peak. But we all have a degree of trainable VO2 as well. So I guess what I don't know is whether there are differences in the percentage that you can increase in terms of training. But I guess it does explain why there is this kind of split between male and females in terms of competitive sporting activities.
So we've come to near the end of our time. Perhaps you can tell us what you're looking forward to in the rest of the conference.
I'm looking forward to having finished giving my own talk. It's always a great turning point in any conference. And I'm looking forward to catching up with some of the people who are involved in the history world. We've got a new curator at the Geoffrey Kaye Museum, so I'm planning to spend some time with her. It's always great to get new eyes on the collection because it really breathes some new life into it. And, you're right about women in history. One of the things I think that I have neglected a lot in my history is women because they're so hard to find. And we were talking off air before about the book I wrote about Joseph Clover. I spent ages trying to find women for that story. They were really, really hard to find. So it is difficult. It's not an excuse, but it is really, really difficult. But we need to try and put them back into our history.
So for more detail, you can read Christine Ball's book,
The Chloroformist.
and it's a great read. I can recommend it. And Dan, what are you looking forward to?
As I've seen some great clinical lectures so far, but there's a social event this evening for the researchers to gather together. So I really want to just get to know some of the local researchers and hear what's going on, and meet some of the sort of younger early career researchers and the ideas that they have. So I think that for me, that's what I'm looking forward to.
So thank you both very much for your time this morning. As always, you can listen to our conversations live on our TopMed app, on our website, on Facebook, on our X account, and also in the conference newsletters. So please do join us in our conversations.
Thank you.
Thanks for having us.
TopMedTalk. Thanks for downloading TopMedTalk. Don't forget to subscribe, check us out on YouTube, and of course on social media. We're on Instagram, Facebook and X. Also, it's important to remember that TopMedTalk is the broadcasting arm of EBPOM, evidence-based perioperative medicine. We'd love you to find out more about that, and the way to do that is ebpom.org. Check out our website and find out about some of the incredible conferences we're going to be arranging across the year. ebpom.org.